Okay, so I'll get started. So this project is all about using a bit of EL wire. So it's much like Michael's project at the beginning, and I just wanted to learn how to do it. So yeah, it was good fun, but as you'll see, I'm just not sure it's a great idea. So I work on the railways, and what we do is we put in control systems for underground. And the system I'm currently working on is called the 4-line modernization project. And it has 4 lines. The Metropolitan line, which comes down here from the northwest of London, comes through and goes into the city at Baker Street, and then travels down to a place called Aldgate. It also has the Hammersmith and City line that starts over here at Hammersmith, and it goes along here and goes out to Barking. And then there's also trains that go around the Circle line here, and they come into Edgware Road, then they come back and go like that. And then there's also a district line, which isn't shown here in a dark color, but district line goes down here and goes over here, and it goes all the way out to the north east of London. So it's the biggest system we've ever done in the world. Lots of different stations, lots of different trains, about 200 trains. So lots of things go wrong. And I always need to know what's going on with the railway. I don't maintain the railway, but if something goes wrong, we have to investigate why it went wrong. And if something goes really wrong, they might phone me up to look for a solution of getting trains running again. So this is the Underground website, and it just shows you all the different problems. So you can see Bakerloo line's part closure, but the ones I'm worried about is District line, part suspended, which is bad. Hammersmith and City is planned closure, so we're doing work there or something. Metropolitan line suspended, etc. And I want to know easily if there's delays and things like that. And I don't have time to constantly looking at the website. So, I mean, you can obviously do the same thing with a screen, and it's a little bit boring. I sort of did that before, so I wanted something quite a bit bigger. NeoPixels are fine, but you've used them a lot, and diffusion's a bit of an issue. It doesn't really look very, very nice, and kind of hard to do rounded shapes. So there's stuff called EL wire, Electro Luminescent Wire, and it does seem really cool. So this is early on when I was just getting started with it. And you can see here, I've got this blue one blinking. I guess that's BBC or something in the background. And you can see here, this one's blinking, and these ones are solid. So you get these different colors, and you drive with an inverter. And I'll talk a bit more about that. So it just seems like a very cool, interesting way of adding light to your project. So essentially the idea is I'm just showing those lines. So if you remember, you have the Metropolitan line here, and then it's the Hammersmith and City shown here, and the Circle line sort of shaped like a beer bottle on its side. And then you've got the District line and the Hammersmith and City line going out like this. So if I just play that, you can see this pink one here is blinking away. And it's actually because it's having severe delays on that line. So you can see here, it says severe delays, Hammersmith and City. So I actually made it so the pink at this point is blinking out SOS dot space dash space dot. So this is showing, if it's seen in the dark, it looks more interesting. You can see this flashing here, the pink one again, it's still Hammersmith and City severe delays. So it turns out it's not our system fault, they don't have enough drivers and things like that. So that's live status that I get. Oops. So the way EL wire works is you have a high voltage, high frequency power supply. It gets driven through this wire here. There's a copper core, and the current passes through this phosphor coating, and that glows. And then you've got a protective sleeve, and then you've got the colored sleeve on top of that. So that's how it works. So you can see here, I bought this set. It's about 10 pounds, and it comes with an inverter, a battery-powered inverter. But this chews up AA batteries quite quickly. So I haven't actually used mine that much, but I read somewhere that you'll only get about 4 hours out of 2 AA's. So it's not a lot of power. Not a lot of, it takes a lot of, spend a lot of money on batteries. So you can buy a 12-volt inverters. And here they've got a panel. So you've got the same sort of idea, except it's a panel. So it seems cheap and easy. You got that, as I mentioned, you either have a 12-volt supply or you got a battery power pocket inverter. So the reason why it's 12 volts is that a lot of people put these in their car to make cool effects. So you control it by a relay or a triac. So I remember, some people may remember Tony Smith's presentation maybe 2 years ago now, talked about triacs and how to use those. I did think it was quite friendly for my application. So creating a tube map. So you get a nice bend radius. You can sort of see how it would work quite easily. And there were some references, so you could sort of go online and see how you would do it. Not that many. I think a lot of people had problems with it for good reason. It's not quite as simple as controlling an LED. So it is fairly easy. So you have a 12-volt supply. So I've drawn this simple little diagram here rather than a circuit diagram, just so people can understand it a bit easier. So here on this side, it's all DC. And then you've got a 12-volt supply going into the red side, the AC side, powering an inverter. And then that goes to the EL wire, electric luminescent wire. So you have a couple of those. So one inverter feeds 2 of those. And that also goes to the triac and then the optotriac. And the optotriac's job is to isolate the DC from the AC. So all this stuff that pins on this side of the DC, that pins on that side of the AC. And so you treat almost exactly like a transistor. So you have your you have a pin you send voltage to, and that goes through a resistor, that goes to ground, and that opens the gate, and that powers the little triac in here, and that powers your main triac. So each triac has 3 pins. So pin 1 and 2 are the power. So this goes on pin 2. So power coming goes pin 2. You fire the gate, which is pin 3, and that goes to back to pin 1, which goes back to the inverter, of course. So the Pi sends a command that operates the optotriac, that operates the main triac, and that provides power to your power to your EL wire, completes the circuit. So your circuit goes like this back from the EL wire back to the inverter. So it's fairly simple, and I've listed the triacs I've used. So I've used this MOC 3041M, and I've used this particular triac for what I was doing, miscellaneous resistors, etc. Of course, and you also have to have your inverter, as I mentioned. So there's a 5-pound version I bought, which I'll talk about in a second, and I ended up with a 15-pound version one. I did struggle with this. I hadn't really played with AC at all, so I did need some help from Tony Smith. So that was very useful to be able to chat with Tony via Facebook Messenger just to get some help. So it's the same thing, just shown in a circuit form. For whatever reason, my mind works better with the little box diagram. But so here you can coming in from your Pi, whatever pin you want, going just a normal I/O, going through a resistor. So this resistor, I think I was actually using a 220 ohm or something. So it goes into pin 1, and pin 2 goes to ground. So that fires your LED inside the chip. And then you have on this side, you've got the triac inside the chip, which obviously you can't send a lot of power through there. It's just for a trigger, and it's zero crossing. It's a zero crossing triac. So then you've got your EL wire be over here. And you can see here it's going through pin 2 to pin 1 and then back out again based on your gate being triggered by the OptoTriac here on pin 3. I didn't actually have this on here, but I did have a 100 ohm resistor in series here with the gate. So if that's clear how that works. Pi turns on the IO, that fires the OptoTriac, that activates the gate on the triac, and current, AC current can flow from 2 to 1 and from 1 to 2 as ACs do. So yeah, as I mentioned, the OptoTriac is mostly about isolating the control from the power. And there's 2 different types of OptoTriacs you can buy. So one is, they call them random, but really you can control them. So if you set the gate high, it just, wherever it is in the waveform, it sort of chops that off. So you can actually measure the waveform and determine where you want to do that. So if you're making a dimmer for your lights, for example, because obviously this would work with your home power. So if you're trying to dim lights, you could do this and use a triac, and that will dim your lights, give you your effective current here. So based on the trigger, it's between 0 and 180 degrees, you set your trigger and that changes the current. So if you got 0 degrees, in other words, you're not triggering at all, so you'd have your full AC wave, then you get the full current. But anything from there, then you get less and less current, so that acts as a dimmer. Such as shown here. So there's your OptoTriac, so you have a little light in there that triggers the triac. So this DC is completely isolated from the AC. Of course, I didn't quite do it right, and I think I burnt out one of my O's in the Pi, as you do. What I actually bought was the zero crossing triac, and what it does is it has a little bit of logic in there, and it looks for when the voltage is very low. So if I trigger my light here, then it waits until it sees the voltage go down to 0, and then it will it will turn on the gate. So it doesn't actually turn on the gate until it gets to 0. As you can see here, if you're turning off the power for 25% of the cycle, it waits until the power gets down to 0 again, and then it triggers the gate until you turn off power to 0 again. So it's just a different way of doing it. So all these things are very cheap. It's just a little IC. So I built a little hat. So you've got the Pi under here, and you got your OptoTriacs here, and you've got your triacs here, and then there's I think some of these are 100 ohm resistors, and I think this may be a 330 ohm resistor, depending on what I was doing and what my thought process was. And you can see here you've got the you've got the Pi underneath the hat here, and just all the bad wiring and soldering I did here. And then I also did a few sort of smaller circuits. So you can see here in this picture here, you can see I've got the connector here feeding off to 2 of these individual controllers. So the power comes, your Pi control comes in from here. So your IO and your ground, and that goes to resistor. And this is the little OptoTriac, which is a little 6-pin IC. And then that connects to pin 4 and 6 on the other side, and that connects to your gate pin 3, and pin 2 goes to pin 2. Your triac goes to pin 4 of the OptoTriac. Then this goes off to your EL wire. I think that's probably clear. So yeah, and there's lots of things that to keep in mind when you're making AC circuits, which of course I didn't keep in mind. So one thing about the inverters is they don't like not having load. So this one here on the right-hand side, I can't remember exactly what I was doing, but clearly I didn't have any load applied. So it just sort of, this coil here, that's the inverter itself, overheated. And you can see here all this black stuff. This is actually melted material from inside the inverter. So I think this was upside down. What I had done stupidly is put it in a little plastic case, because these things whine like hell. You know, they make a whining noise. And I've got two 20-year-old-ish kids in my house, and they can hear the whining much better than I can. So it's like a high frequency pitch. So I'd put in a little plastic box to eliminate or minimize the pitch. And of course that made it heat up even better. So all this melted material here. And then I think what happened is I realized what was happening, that it was getting hot. And I picked up the little plastic box I had it in, and immediately all the molten material sort of dripped down and melted this and started melting onto capacitors, etc. So it made a huge mess inside. So this is the best I could do, is to take the cover off. I couldn't actually get it all deconstructed. So this is the 15-pound one I bought later. It's a little bit more robust. I don't know if it has the same problem. I don't know if it'll actually melt the inverter if I don't have a load, but I'm not going to take any chances. This one has a simple little switch here that you can either switch it on or off, which this one doesn't have any switch or anything. But it also has a blinking mode, so you can make it blink. So if you only had this inverter hooked up in your car, for example, you could hook up some EL wire and you can have it blink without any code or anything. Keep in mind, so I measured the output voltage of this one. I think I measured the output voltage. This one is about 115 volts, and this is 150 volts. Just something more robust to drive longer EL wire. It does hurt if you electrocute yourself, it turns out. And if we just go back to the last picture. Oops. Yeah, so all this is live. So all this is 150 volts. So touching any of this stuff here, or touching anything here, that's 150 volts that you're introducing to yourself. Yeah, and it does make this whining sound. So this one was very bad. It's quite a high pitched scream. This one's a little bit less whiny, but not much. It's just a little bit beefier, so I guess the frequency is a little bit lower. And it may also just be my ears. I'm 54 now, so it could just be that maybe my kids are screaming in pain. I don't know. So there's a bunch of rules that you're supposed to apply if you're smart. So after I had already made a big mess of things, I'd contacted Tony, and he just shrugged his shoulders about some of the stuff I was doing. So there's things called clearance, which is the distance between components. And then you've got creepage, which is the travel distance. So you really want to make sure things are isolated well. And I don't know if it shows up very well, but what I ended up doing is I drilled out all the holes underneath the IC here, and I drilled out some holes here as well, just to reduce the amount of potential for sparking from the 150 volt source to the little solder pads. Yes, all this is driven by the Transport for London website. So it uses the REST API, so representational state transfer. I use this in one of my previous projects. So you just really, as Ben was pointing out, you need an API keys. You get that from TFL. It's all free. Just ask for it and they give it to you immediately. And then you use those keys to get access. And then I guess the only slightly complicated bit is you have to interpret the JSON coming back, or XML coming back. But that's not that difficult. You just have to spend a bit of time on it. So it's all fairly straightforward. So some of the things I learned, so getting electrocuted is not cool. Inverters without load are bad. Inverters are noisy. EL wire is cool, but maybe fiber optics and LEDs are better. And REST is useful to know. So you can see here you've got, so this is what the fiber, what I was able to find for fiber yesterday. So you buy the fiber like this, separately, and then you buy these, they're called fiber optic projectors, and you can just sort of plug your fiber into these depending on the size of fiber you've bought, and then you just control the LED, and some of them are single light LED, and others use neopixels, so you could change the color. And after doing all this work and getting electrocuted a few times, I looked on a website, and this guy was talking about why he never uses EL wire anymore. He uses fiber optics for his clothing. I thought, oh, great, why didn't I read that in the first place? But yeah, it was pretty cool to learn all that stuff. I guess that's really it. So I do have, if I just stop sharing for a second. So I don't know if you can turn my camera back on. Assume you guys can see me again.
Yeah.
Yep.
So just let me just put this down. So I can't quite see myself. So I don't know if you can see the project there. Why can't I see myself?
No, it's very smart.
You can see it. So I guess one thing I learned, so I don't know if, so what can I see myself?
Is it because you're not actually in vision? You're pointing your camera at your sofa.
No, I can't see that either. Okay, so anyways, I don't know if you can see the white light there, but that's sort of a sacrificial one. So I decided that I thought I could either build a dummy load, or I could just use one of the EL wires just to make sure that the inverter is always loaded. So that's what the white one's for. And I did manage to break one of the wires, the EL wires. Apparently you can repair them, but I just don't know if it's worth it. With the fiber optics, you can literally just take a little X-Acto knife and cut it to whatever length you want and sort out that way. So it just seems like a much better solution. Gets rid of all the whine, and sort of it's much easier to control, and you're not dealing with AC currents, which are no fun to be electrocuted by. Any questions on any of that? Hopefully that was clear. I don't know if that was clear or not.
Did you not think of using a battery with a trickle charge to it?
A battery. Well, it needs AC. Oh, you mean for a 12-volt supply?
Yeah, and then
Well,
you've got a trickle supply to it, and then a trickle charge to it.
Yeah, but the 12-volt. I mean, the 12-volt supply is not the problem. It's going via the inverter. So once coming out the inverter on the other side is the AC voltage. So regardless of what you use for the DC side, you've got AC coming out the other side. The EL wire requires AC to work. It doesn't work at all with DC.
Right. No, I've not worked with it, so I didn't know.
Yeah, I think I would summarize it as that, you know, it is worthwhile. It is worthwhile playing with. I just don't know if I would use it for something that's sat there unattended for long periods of time, sort of thing. I think it's probably a good something that's worth playing with. And if you look on the website or say the if you look at Amazon, for example, where they sell the inverters and stuff like that, those every once in a while you see a 1-star and they'll say it melted in my car and stuff like that. So it's, you know, it's just, and I'm thinking, oh yeah, so this is, I mean, the cheaper one, the 5-pound one, I got that from Pi Hut, I think it was. And they do say, you know, you got to make sure it always has a load, otherwise it could damage things. So, so someone asked what current was I drawing? I don't actually know what current was drawing. I don't think it's a lot. I just had a little 12-volt, you know, 12-volt, 3-amp sort of cheap DC supply. So I don't know what the AC was actually doing.
Do you notice a change in brightness on the ones that are turned on when you're flashing one of the other ones?
No, it doesn't seem to affect it.
Yeah, so it sounds like it is low current. It's high voltage, low current, doesn't it?
Yeah, it'll be low voltage, low current.
Yeah, that's probably why. So yeah, that's why you don't see a difference. That's quite cool.
Yeah, it is fun to work with. I mean, I wouldn't want to dissuade people too much, but it depends what you want to do. I just think the fiber optics is probably the way to go. It's quite cheap and quite good. Somebody asked about fiber optic projectors, 50 quid. I mean, you can get really cheap ones for about 5 quid that just have, very weak little 12 volt LEDs of different colors. So that seems to be, I guess it depends on your application, of course, but it might be enough. I guess the other thing to point out is when you're using the fiber optics, you need the, they're called side glow fiber optics, not end glow. So the side glow does apparently, it has it allows light to leak out the sides essentially. And I saw someone saying you need to put a mirror or drive it from both ends. Otherwise, a lot of the light you're providing sort of leaks out the end anyways. So this isn't like the fiber optics you use in communications, for example.
I was going to say the advantage of what you've put there is you would have a more consistent light distribution across the length of your string, wouldn't you? As opposed to with a optic, you'd have a bright source at either end.
Yeah, I guess so. I don't know how dramatic that is, and I think for my particular project, I'd probably have some of the cable hidden behind anyways, so you probably wouldn't see both ends. Yeah, so I think that'd probably be okay. I mean, the EL Wire, I encourage people to give it a try, but don't put your hopes into it too much. The smell of melting plastic isn't too cool.
You could try to create a PCB and then design all the lines with a NeoPixel.
Yeah, with NeoPixel you could do it.
Like you get the individual chips of lights, and then you basically design a PCB, and then you can kind of like maybe create an acrylic with routing inside, so diffuse the lights, and you can create your own kind of interactive map with NeoPixel.
Yeah,
I know probably it's expensive, but you can actually maybe create more animation as well.
Yeah, I did think about that. I mean, if you go to the TfL website, you can actually get a list of all the trains, and it'll tell you where all the trains are.
Yeah.
So you could actually plot all the trains, and I think there's a project that did that. They sell little PCBs with those little trains showing, and that'd be good, useful information for me. For example, if the trains are all bunched up, I know I've got a problem and that sort of thing. Yeah, it's just really just different things, really different ways of doing it. Sorry, Brew, you're asking about what's the PCB mount terminal connection?
Yeah,
device?
you had the terminal strip that you had on the you had on the end of your PCBs. It looked like it was quite a big piece that was quite solid onto the PCB, whereas the ones that I've seen only seem to be quite short, so can break off with fatigue a bit easier. So I just wondered what they were.
You mean the green ones?
Yeah.
Yeah, get those. You can get those from RS Pro. Yeah, RS Pro headers. I can post that into Facebook or somewhere to.
Yeah, no, that'd be cool.
A link. Yeah, they are really good.
Obviously, there's like a million of them on RS, isn't it? So it's just which particular one you want.
Yeah, but it's the RS Pro brand, 2-terminal, 2-terminal header, and it's the 2.54 mil spacing, or the 5.08 spacing. But they're really, really good. They're keyed, obviously, so you can't put them in the wrong way and things like that. So it's just, they're very, very good. They're not expensive. They're just I can't recommend them more. They're really good. Any other questions? All good? Great. Thanks very much, everyone. Hope you enjoyed that.
Yeah, thanks, Richard. Really good.
Yeah, no problem at all.
Yeah, great.
Yeah, thanks for the invite. Been very interesting. Learned a lot. Thank you.
Cool.
Um,
So our next presentation is the 27th of April. So I don't know if anyone's got any ideas or anything they want to present, then let me know.
Richard, I was just wondering if you had details of, because I had a brief look around the TfL API, and I was interested to see if I could see where the trains were, but I couldn't actually find where that information was. Do you have a link to the particular hook that it gives that?
Yeah, it is a little bit difficult because you have to, what they provide is predictions. So it tells you, if you look at I think it's the platforms, or maybe it's the stations object, and it tells you the trains that are approaching that station. So I think you have to work your way through the stations, which is a bit of a pain, but.
Right, so you have to kind of go, well, this one says that there's trains that are due in 5 minutes, 8 minutes.
Yeah, but it tells you where the train is, though. It says this train is between Hammersmith and Ladbroke Grove, or whatever the next station is. I should know this.
Right.
Or Edgware Road and Paddington. I know those are close, right next to each other. Yeah, so it tells you, whether it's at a station or whether it's between stations and that sort of thing. Right. So you do have to do a bit of work, but it's not too bad.
Okay,
it's doable for sure.
Sounds good. I was thinking of doing just a little one just for the little branch that I'm on of the central line, so I could show where the trains were just kind of coming and going. So
yeah, and you can also get the departure board, so that obviously the trains arriving, from that data you can tell where the trains are going and when they're going there and that sort of stuff as well. So you can have your own little departure board.
Yeah, you could have a string of adjustable LEDs to show where the train is.
Yeah, I was thinking about that. So you need two of them because you got to show the southbound and the northbound, for example.
Yeah.
Yeah. Yeah, just takes a bit of work, really.
Yes.
Yeah, it's a bit hard. They don't bend in quite the same way, do they? LED strips.
Yeah, you may have to go for individual ones, or as Christian said, you could do a custom PCB and put them exactly where you need to put them and stuff like that. Yeah, it ends up being a fair amount of work, I think.
Yeah, I did see somebody who was trying to sell the Northern Line as a kind of an LED thing that showed where the trains were. That talked to the TfL API. It looks like it ran off for like an ASP8266 or something along those lines.
Yeah.
So that was kind of interesting, but yeah, Northern Line's pretty irrelevant on its own.